In our first problem, as usual, well, not in every single case, but in this particular case, as is often on the CSEC examination papers, we will be manipulating fractions. Convert mixed numbers to improper fractions and make use of a division sign. Of course, we have a single fraction here, and this line indicates that we are going to be dividing by all of this. So instead of using this line again and again, causing the expression to look very cumbersome, we will use a division sign. Of course, it is going to be appropriate to enclose this entire expression, this entire lower expression, by brackets. So 4 3s 12 plus 3 15, so we have 15 over 4. We have 3 2s 6 plus 1, so we have 7 over 3. And of course, this is not a mixed number, it goes back exactly as it is. That will also go back as it is, and we are going to find a common denominator, that is the smallest number that 3 and 6 can go into without leaving a remainder. And then we say 3 into 6, 2, 2 sevens, 14. 6 into 6, that is 1, and 1 multiplied by 5 is 5. But of course, this subtraction sign will go there first. We are going to simplify 14 minus 5, and of course we are going to, in the next step, invert and multiply. So, of course, when dividing by a fraction, we may multiply by its reciprocal or by its inverse. And that is what is done right here. Reduce 9 and 15 by a common factor of 3. Then reduce 4 and 6 by a common factor of 2. 3 into 15 is 5, and 3 into 9 is 3. 2 into 4 is 2, and 2 into 6 is 3. Of course, these three will cancel each other, and the answer is 5 over 2. We now have a problem that requires us to manipulate foreign exchange. But in this particular case, the rate is not going to be given to us at first. We are going to use a table as it is customary with Richard James Mathematics Resources, and the amount of Barbados currency and Eastern Caribbean currency will be placed in their appropriate places. We need to find out the Eastern Caribbean equivalent of 1 Barbados dollar. So we need the Eastern Caribbean equivalent of 1 Barbados dollar. We therefore need $1 on this side. In order to get that, we need to divide by 2,000. Reducing the Barbados side to $1 by dividing by 2,000, we also need to divide the Eastern Caribbean side by 2,000, and that will result in the Eastern Caribbean equivalent of 1 Barbados dollar. So 1 Barbados dollar is equivalent to $1.35 Eastern Caribbean currency. In this particular case, we are going to make conversion between currencies, and we are going to use the rate that we have that was already calculated in the first part of the problem. So that is our rate already noted in the first row of the table, and the Eastern Caribbean amount is given as $432. Now, by considering the figures that we have in the rate, we realize that on the Eastern Caribbean side we have a larger figure than what we have on the Barbados side. Converting this to the Barbados currency will result in a figure that is smaller than $432. We will therefore divide by 1.35. So 432 divided by 1.35. That is if we want to be consistent with the sizes, the relative sizes of the figures that are given in the first row of the table. And that is the reason why we have the table. The purpose of the table is that we try to be consistent with what we have in the first row of the table, and we use that as a guide to know when our answer is correct, or if we have made the correct decision by multiplying or dividing. So if we are going to be correct, then the smaller figure will have to be on the Barbados side, and of course there's no doubt that we have it right here, $320. Volume 4 of Richard James Mathematics Resources has given a simple process by which we may make calculations involving compound interest and depreciation. We are going to do a brief summary of the process right here in the solution of this problem. For greater detail of this problem, consult Richard James Mathematics Resources Volume 4, Computations Part 1. We are required to determine the amount of money that will be received if $24,000 were to be invested for 2 years, if interest accumulates at the rate of 8% per annum. So, since we are increasing by 8% each year, the original is 100%, so we will have at the end of the year 108%. 108% is 108 divided by 100, which is 1.08. After the first period, we will have, or after each period, we will have 1.08 times the amount that we had before. We have 2 periods, therefore we will multiply by 1.08 twice. So the original amount of money will be multiplied by the square of 1.08. 1.08 multiplied by 1.08 is equal to 1.08 squared, and that is what we have right there. And just use your calculator in this particular case, and the result turns out very quickly to be $27,993.60. There's a little bit of catch to this problem, because sometimes some students, when they see an increase by 8%, they jump immediately to divide by 1.8. But it is for us to take careful note of the figures that are given to us. We do not multiply by 1.8. Multiplying by 1.8 is an increase by 80%. So increasing by 8% is up to 108%. And of course that turns out to be 1.08. Simplify this rational algebraic expression. We'll take the same approach as we take when we are manipulating fractions at the primary school level. The only difference is that we are going to be manipulating algebraic expressions. We'll take the smallest expression that n and 3n can go into without leaving a remainder, and that is 3n. So we say n into 3n is 3, and 3 times 2m is 6m, then we say 3n, this is it, 3n into 3n is 1, and 1 times 5m is 5m, and then we simplify the numerator. 6m minus 5m is m, and we have m over 3n, and that is our answer. Binary operations. A asterisk b is equal to a squared minus b. So if we have 5 asterisk 2, we'll have 5 squared minus 2. So that is 25 minus 2, and the result is 23. We have a quadratic expression. It is a quadratic because it has 4 terms. We have a quadratic expression to factorize. So we are going to be using factorization by grouping. So we will of course take the terms 2 at a time. So we need to find the common factor of these two. What can go into 3x and go into 6y? Of course 3. So 3 is our common factor, and then we say 3 into 3x is x, and 3 into negative 6y is minus 2y. So we'll have x minus 2y right there. In this one, the common factor is x. So x into x squared is x, and x into minus 2xy, only the x will cancel, so we'll get 2y. So it is again x minus 2y. X minus 2y is the common factor, and the remaining terms will occupy the other bracket. In this problem, a drinking straw is cut into 3 pieces. The length of the first piece is x. The other piece is 3 centimeters shorter than the value of x, or than the first piece, because the first piece is x centimeters long. Therefore, 3 centimeters shorter will be x minus 3. The third piece is twice as long as the first. Twice as long just simply means 2 times longer. So 2 times this. So we have 2x. We'll have to take note that the total length of the straw is 21 centimeters. We are going to find the sum of all of these, and that will be equal to 21, because 21 centimeters is the length of the entire straw. We will then solve the equation to determine the value of x. All the x's together, x plus 2x, that's 4x. And of course, this negative 3, by transposition on the other side, we will have a positive 3. 21 plus 3 is 24. 4x is equal to 24. And x is equal to 6, dividing both sides by 4. A school has 90 students in Form 5. 54 students study physical education. 42 students study music. X students study both PE and music. 6 study none of the subjects. So place the information in the intersection of the two sets first. Of course, we have X study both PE and music, and 54 study PE, but X of them are in the intersection. Therefore, those who are unique to physical education will be 54 minus x. And of course, 42 study music, but we have x in the intersection. Those unique to the set of those who study music will be 42 minus x. And do not forget, 6 of them study none of the subjects, therefore they will be placed inside of the Venn diagram, but not in any of the sets that we have there. The number in the survey will be the sum of the numbers in the different section. We are going to write that. Those are the number of students in the survey. All we have to do is add 54 minus x, 42 minus x. We have x right there and we have 6 right there. Next, we will solve the equation to determine the value of x. So, all of the x's remain on the left-hand side, and on the right-hand side we have transpose all of the numbers. Negative x is equal to negative 12. So, positive x is equal to positive 12. So x is equal to 12. Given the particular setup, we are first required to find the length km. Of course, km is one side in a right angle triangle that we have right here highlighted. So, in this right angle triangle, km is opposite to the known angle and the hypotenuse is also known. So, if we are going to be using hypotenuse and opposite, or opposite and hypotenuse, we know that we are talking about the sine trig ratio. And of course, sine is equal to opposite over hypotenuse. So, we will have km over 10, and that will be equal to sine of 30. Or we may have sine 30 equal km over 10. But quite likely km over 10 is equal to sine of 30. We are dividing by 10 on this side, so multiplying on the other side we have km is equal to 10 sine 30. Sine 30 of course is equal to 0.5, so we have 10 times 0.5, which is equal to 5 meters. In the other case, we'll be required to find jk. However, we cannot find jk immediately. We will have to find jm first, and then make use of the km that we have found before. So we already know km. To find jk, we need to find the length of jm. jk will be the difference between the two calculated values. We already know km. To find jk, we need to find the length of jm. jk will be the difference between the two calculated values. So we need to find jk. So we know km already, so we find jm, and we will then subtract the value of km from that value that we have. We are going to make use of the other right angle triangle that we have. In the other right angle triangle, we have two sides already. So the other triangle is right angled. Two of the sides are known. We may use Pythagoras theorem. One short side is missing. We need to use the difference between the squares. So generally when students come across a right angle triangle with two sides already given, they just jump straight ahead and use Pythagoras theorem, saying the length of the other side is equal to the sum of the square of the other the length of the unknown side is equal to the sum of the squares of the other two sides. In doing so, they may make a mistake if one of the short side is required. And of course, we already know that if we need to find one short side, we subtract the other one from the square of the hypotenuse. And that is discussed in detail in Richard James Mathematics Resources, Volume 6, Trigonometry. So what we will do here, since we are required to find one of the shorter sides, the hypotenuse being the longest side, we are going to subtract the squares. If students make a mistake and add the square instead, at the end they should realize that the answer that they receive is wrong, because there is no side that can be longer than the hypotenuse. So by adding the square, the result will be a value that is larger than the hypotenuse, and that we cannot have in a right angle triangle. So it would be, or should have been, obvious that a mistake was made. So we have Jm is equal to the square root of 13 squared, which is the hypotenuse squared, minus the length of the other short side square, or the square of the length of the other short side. 13 squared is 169 and 5 squared is 25. Subtracting the result, we get Jm is equal to the square root of 144, and of course Jm is equal to 12 meters. So that is the entire thing. Jm is 12 meters and Km is 5 meters. So Jk is equal to 12 minus 5, which is equal to 7 meters. This line is passing through 2 points, P and Q. We need the coordinates of P and Q. P, the first point, crosses the y-axis at 3. Therefore, the value of x, or the x-ordinate in that particular case, will be 0. So we have the line is passing through that point P, which has coordinates, no movement in the x direction, 3 in the positive y direction. So we have the coordinate is 0, 3. And of course for Q, Q is on the x-axis, no movement upwards nor downwards. We therefore know that the y-ordinate is 0, and of course we are down to x equals -2. So the coordinates of that point will be -2, 0. Determine the gradient of the line segment. For m, which is the gradient, we do not have to do a calculation based on some formula. We can just put the movement in the y direction over the movement in the x direction, or the x difference over the y difference. Now, students who do physics and other mathematical subject that requires us to use graph, in order to determine the gradient of a line, we generally draw a little triangle. In this particular case, we have a triangle already drawn, and then we can just use this over this. So we just look at the movement to get from P to Q, and that will help us to determine the gradient. So m is equal to, we go -3, we are going down like this. So -3, because we are going in the negative y direction, and then we go this way, which is -2 in the x direction. So we go down, which is negative in the y direction, by 3 units, so that is -3, and then we go to the left, which is negative in the x direction, so that is a -2, and of course the gradient is a +3/2. How comes we can tell that our answer is correct being positive? The line that slopes in the direction of the uplifted right hand always has a positive gradient. the equation of a line is given as the general form y is equal to mx plus c. We have m, the gradient is 3 over 2, and we have c, which is where it crosses the y-axis at 3. So it is going to be y is equal to 3 over 2x plus 3, because m is the gradient and c is the y-intercept. No problem, y is equal to 3 over 2x plus 3. The point negative 8t lies on the line segment PQ, and we are required to determine the value of t. So in the point, negative 8 is the value of x and t is the value of y. So we will substitute those inside of this equation. Where we see y, we put t. Where we see x, we put negative 8, and see what happens. So we have t is equal to 3 over 2 negative 8 plus 3. So we have t is equal to, what do we have? 2 into 8 is 4. So we have a negative 4 times 3. So we have a negative 4 times 3. So that will be negative 12. So we have t is equal to negative 12 plus 3. So t is equal to negative 9. So t is equal to negative 9. We have information telling us that the line segment is perpendicular to another line that passes through 6, 2. We are about to determine the equation of that line. So this line segment is perpendicular to another line segment, and that line segment passes through 6, 2. We have two things that we need to determine the equation of a straight line. One, the point, which is 6, 2, and of course the gradient. It is not very far away from us. It's right in our grasp to determine the gradient of the line that is perpendicular. For perpendicular, if we are going to determine the gradient of a line that is perpendicular to another whose gradient is known, we will reciprocate the gradient and change its sign. So the gradient that we have here is 3 over 2. So the line that is perpendicular to this, we will invert this 2 over 3 and we will change the sign. The sign is positive, so we will change that sign to negative. So it will be negative 2 over 3. So that is the new gradient, and the point is this. And of course we will use y minus y1 is equal to gradient x minus x1. So y minus y1, which is 2, is equal to gradient, which is this, x minus x1, which is 6. Simplifying, we have negative 2 over 3 times x, we have negative 2 over 3x, and of course 3 into 6 is 2. Of course it's a negative 2, so 3 into negative 6 is negative 2, and negative multiplied by negative is positive. So we'll have 2 times 2 is 4. And we need one more bit of transposition, which is this negative 2 to be transposed, and we will have a positive 2 right here. So the equation will be y is equal to negative 2 over 3x plus 6. Here we have our cereal box, and we have its dimension. First thing we need to do is to determine its volume. Volume of a rectangular prism may be found by finding the product of all dimensions, length multiplied by width multiplied by height, in any order. So we will have 25 times 8 times 36, of course, in any order. And that is equal to 7,200 centimeters volume, so centimeters cubed. The total surface area is the sum of the areas of the 6 sides. There are actually 3 pairs of sides. In a rectangular prism, we will have at worst 3 pairs of sides. Of course, this face is going to be equal to the one at the back right here. And the one at the top is equal to the one at the bottom, and so on. So we know that whatever we have here, we will have it again at the back. So we'll have the area is equal to 2. Remember that we have each face occurring twice. So we have 2 times 25 times 8, and we have 2, 25, 36, and we have 2, 8, 36. Putting those together, we get a total of 2,776 centimeters squared. The cereal from one large box can exactly fill 6 small boxes, each of equal volume. So we need to determine the size in volume of each cereal box. All we need to do is divide the volume by 6, and we get 1,200 centimeters cubed. Now, this problem is not very difficult to solve, but I think that by asking that question immediately after this one, some students will divide the 2,776 by 6, and I think that that probably could be the only catch to the problem, that students will just jump to divide this one instead of this one by 6. So we need to be very careful of what we are answering. The question requires us to calculate the volume of one small cereal box, and it says the cereal from one large box can exactly fill 6 small boxes, each of equal volume. So we have to be careful when we are solving problems like that, that we do not just jump and use the figure that we have just calculated, but we will use the appropriate one, the one that is suited to the solution of the problem. If the height of a small box is 20 centimeters, list 2 different pairs of values which a company can use for the length and width of a small box. So of course, we know that the dimension of the small box, one of this dimension that is given already, 20 centimeters, we know that if we divide that value into 1,200, the result is the product of the other 2 sides. So we have divided the 7,200 by 20, and that will be the product of the other 2 sides. Now choose any 2 pairs of numbers whose product is 60. We may now choose any 2 pairs of numbers whose product is 60. So we have, to get this 60, we may use 15 times 4, so that's a possibility. And we may use 12 times 5, that's another possibility. Of course, we have other possibilities. But the statement of the problem requires us to choose 2. Now we have our ever-present construction problem, and we need to construct a rectangle whose dimensions are specified. So let us go straight ahead. So we draw the line PQ is equal to 7 centimeters. That is our first task. 7 centimeters. Because we are constructing a rectangle, we know that we need to have a right angle right here. We are going to go through the necessary process in order to construct a right angle right here. So let's do that. Extend the line at P with a construction line. Place the compass point at P and make a semicircular arc as shown. So that's our semicircular arc right there. So the compass point will be at P and we make a semicircular arc. What do we do next? Place the compass point at the point of intersection of the construction line and the arc and make an arc. So we have the construction line right here and the arc there. So that's the intersection of the construction line and the arc. So let us put the compass point there, the red dot. The red dot is our compass point and we are going to make an arc. Good. Then we are going to move the point of the compass to the point of intersection of the line PQ and the first arc. So this is the first arc. It's point of intersection of this arc, which is this one, and the line PQ, which is right there. We are going to put the compass point right there and we are going to make another arc. Place the point of the compass at the point of intersection of one of the small arc and the semicircular arc. Any one we can choose and make an arc. Well, we have chosen to do this one first, so we make another arc. After that, we will move to the next one, which is this one. Move the point of the compass to the other point of intersection of the other small arc and the semicircular arc and make an arc again. No problem with that. Draw the line that goes from the final pair of arcs P to the line PQ. So we are going to go from P to where the final pair of arcs intersect, and that will be our perpendicular. Construct a perpendicular at Q by using the same construction principles as the one at P. But we are not going to go through that entire process since we are familiar with the process already. So we'll just put the construction lines there. Draw PS equal 5.5 centimeters. And draw QR equal 5.5 centimeters. Right. Then, of course, complete the rectangle PQRS. And that's all there is to it. We have three triangles, L, M, and N. L is mapped onto M by a translation. State in the form xy, that is in the form of a column vector, the vector which represents the translation. That is what we are going to do. We have what? This is translated to this one, so we need to determine the vector of translation. So take a look at the movement from a point on L to its image on M. So we move 1, 2, 3, 4 units in the positive x direction and 1, 2, 3, 4 units in the positive y direction and 4 units in the positive y direction. So the vector is 4 for the x, 4 for the y, so we have 4, 4. L is mapped onto N by an enlargement, and we need to find G, the center of enlargement. To find the center of enlargement, extend the lines that join points to their images. So we are going to draw one like that. So we have this point to its image, and we extend that line all the way across there. And of course, we are going to take another one, probably this one, that join this point to its image all the way across there. And of course, where those two lines intersect will be the center of enlargement G. And of course, we need to write down the coordinates of G. That's not difficult. We have all the way to -5. So -5 for the x, no movement for the y, -5, 0. And the scale factor, we need to determine the scale factor of the enlargement. So compare the length of a side and its image. So we have this side 1, 2, 3. So the original is 3 units. The image is 6 units. Let's see for sure from here. 1, 2, 3, 4, 5, 6 units. So scale factor is equal to image divided by original. So scale factor is 6 divided by 3, and the scale factor is equal to 2. Our favorite. We have our statistics problem now, and we will first complete the cumulative frequency column. So let's go. Let's complete the cumulative frequency column, and that is done by doing what? The present item in the cumulative frequency column is added to the next item in the frequency column. So we have this one. So 16 to be added to 14, and we get 30. So that goes there. Then 30 added to 16, we get 46. That goes there. Then we get 46 added to 12. That's no doubt 58. Good. Then we have 58 added to 8. That's 66. Then we have 66 added to 4. And that is 70. Goes right there. Then, of course, we will draw the cumulative frequency curve. The cumulative frequency curve is drawn by plotting the cumulative frequency against the upper class boundaries. For calculation of upper class boundaries, see statistics in volume 5 of Richard James Mathematics Resources. So now let us plot against upper class boundaries. We have 10.5, 2. So we first go to 10.5 and then go up to 2, and of course our point will go right there. Next we have 20.5, then we go up to 7, right, and 30.5 will go up to 16, 40.5 will go up to 30, 50.5 will go up to 46, 60.5 goes up to 58, Of course, at the end of every set of coordinates, we will place a little x that indicates where the point ought to be. And of course, finally, that one. We will generally cause the curve to go down to where the upper boundary of the previous class, the one that is previous to the first, would have been. If we keep going down by 10 each time, there is no doubt that the upper class boundary of the one previous to the first would have been at 0.5. However, the statement of the problem requires us to state the assumption that would have been made in drawing your curve through the point 0, 0. So they require us to draw the curve through the point 0, 0. And what would be the assumption there? The assumption would be that the upper class boundary of the class previous to the first would have been at 0. So that's the assumption that would have been made, that the upper class boundary of the class previous to the first would have been at t is equal to 0. And then we complete our curve. For a computer generated curve, I think that is very smooth. The pass mark is 47. Use your graph to determine the number of students who passed. So that is what we need to do. Use our graph to determine the number of students who passed. If the pass mark is 47, so we go to 47 on the marks axis and then draw a vertical line to meet the curve. We will then draw a horizontal line to meet the cumulative frequency axis. And of course, you need to determine the number of students who passed. So those who pass are in the region above, which is there. We have two reasons why students generally might not get the correct answer. One, when we get to 40, we just put the 40 down and use that 40. Totally absent-minded of the fact that we are talking about those who passed, and those who passed need to be above the mark that we have here. Also, because a particular student might put values up to 100, they may subtract the 40 from 100. Again, neglecting the fact that the total cumulative frequency is 70, so we cannot go above 70. So we will have what? 70 minus 40 is equal to 30. So we will have 30 students passing according to the information that we have on this graph. Remember that we need to use the information that we have on the particular graph. A graph that is drawn on a grid, on a graph paper, might well give a different answer. And as a matter of fact, the graph that is used by Richard James Mathematics Resources, the grid that we have is not in centimeters, or for the bigger squares, not in 2 centimeter squares. So that is some discrepancy that we may have. Of course, the graph is accurately drawn, and we need to make use of the figure that we get from the particular graph. So what is the probability that a student chosen at random has a mark less than or equal to 30 marks? So go to 30 marks again and go across. Those whose marks are less than or equal to 30 are in the region below. So they are in that region. So we have 15 of them. And the probability requires us to divide by the total cumulative frequency. So divide 15 by total of 70 to get the probability. So the probability is equal to 15 divided by 70, which is equal to 3/14.